In this lesson, we're going to look at how we formally prove similarity. It's going to have a lot similar with congruency, but there's a few things that are different. Now, first thing, we have looked at the similarity tests in class, but it's important to know that with these ones, we can't just write, as with congruency where we could write SSS, we can't just write SSS. We have to say something like 3 sides are in the same ratio. That's because both of our triangles aren't the same, so we can't write SSS. Likewise, we can't write SAS. We have to say 2 sides are in the same ratio and the included angle is equal. The same with the following 2 as well. But these are the tests. Make sure that you understand that these are the acceptable tests for similarity of triangles. Okay, with these 2, we're going to try to prove they're similar. So we can see we've been given 2 angles. And if we're given the 2 angles, we know that the 2 triangles are going to be similar if the angles are the same. So this one looks a lot like congruency. We start off by saying that in these triangles, and then we give our proof line by line, again, giving the reason why we say that thing. So we've said that both of these angles are equal to another angle in the other triangle. And then finally, we can say that therefore these 2 triangles are similar. Now, if you haven't seen this before, remember congruent triangles are like this. Similar triangles are rotating it a bit. We're getting 3 lines, 3 vertical lines. So this here means they're similar. And then afterwards, we need to give a reason. The reason we're using here is that we have 2 angles are equal. Here's our second example. This time we're given 3 sides and no angles, so we're going to have to use the rule that 3 sides are in the same ratio. Again, we start off like usual, writing in these 2 triangles, and now we're going to go through and for each pair of matching sides, we're going to find out the ratio of them. We want to make this the same for all of them. We also want to leave this as a fraction because, again, we're finding a ratio, so a fraction shows us a ratio. We could simplify this to 2, but it just doesn't show the ratio as easily as the fraction would. So we're going to leave it in a fraction. We go along, we're going to get these 3 things. So you can see here AB corresponds to DE, so we've put them on top of each other, BC and DF, and then AC and EF. Okay, so now that we've done this, we've shown that they all have the ratio 2 to 1. We need to, and it is a bit of a pain, but with similarity, there is a lot of writing in our proofs. And we need to actually write out that the 2 sides are in the ratio of, and then whatever the ratio is here. And they need to be in the ratio that is the same for similarity to be proven. So we get those 3, and then we can write, therefore, these 2 triangles are similar to each other. And this time the proof we're using is that there's 3 sides are in the same ratio. Now it's your turn. Have a go at this one. The proof we're going to use is that 2 sides, so you can see that these are hopefully, so we've got this side matching this one matching this one. Hopefully they're going to be in the same ratio. And then we've got the vertically opposite angles. I'll change the pen. So we've got these vertically opposite angles here are going to be the same. So we're going to have 2 sides in the same ratio and then the included angle also being equal. Have a go writing out your proof. As usual, we start with the in these triangles statement. Then we're going to find the ratio between the 2 pairs of sides. So we've done that. In both of them, it's 3 to 1, which is good. We've got a same ratio. So we can say that these are in, we can say the first 2 are in a ratio of 3 to 1. We can say the second 2 are, and we can also then tell that this vertically opposite angle is the same. And we've put our reason there. Finally, we can put our similarity statement saying that these 2 triangles are similar. Now, the reason we've used is a bit wordier than the previous 2, but we said that the 2 sides are in the same ratio, which we've been proving, and that the included angle is also equal. Now, if you have any questions, please bring them to me. We will be practicing some of these in class. Thank you.